welcome to another problem session. Okay, today it's a problem from AC circuit. So as you probably, if you're regular to this channel, you know that we are doing, these days we're doing problems from JEE 2025. And this is question number 15 from paper 1. All right, let's do this problem. We can do it like several ways. I'm going to do one way to illustrate to you a little advanced method, and kind of nice to know that. All right. So this is a sinusoidal source, AC source. This is the AC source. Normally it's written as cosine, but this one is sine. That's fine, no problem. Sinusoidal can be sine or cosine or a combination of them. And so this is this, and the unit is volt. This V is the variable, and this V is just volt. And this one stands for EMF, electromotive force. That's over here. Sometimes called voltage. Also called voltage. But this is not electric potential, right? Electric potential will be static concept. You can have a when it becomes dynamic, we start to call it like EMF. All right, so let's see. T is time in seconds, so because no unit is inside, this 400 T, its unit together will be unitless because I take a sign. So this 400 is in 1/second. So this is second. Sometimes you see this is radian per second because this whole thing is in radians. Okay, but I don't like to think that way, but it's okay to think that way. There's no problem with that. Okay, so a whole bunch of different answers are possible based on this Z. So what is Z? This Z is impedance of the circuit. So this Z is the, in this case, it stands for this element. That Z stands for this together, and over here stands for this whole thing. You can see this coming out, and so these are all different values of Z. This is Z here, Z in the part Q, this for part P, for part possibility R will be Z. So you can see there are 4 problems here. So you have to solve this. You don't have to solve all 4 problems because I will just share with you that just after we go. So it says which of these answers, so there are 5 answers here. So one clearly doesn't belong here, but which one of these answers, from list 1 corresponds to list 2? Okay, so there's only one unique matching, and out of like there's 4 choices, and one of these is correct. And so actually this problem doesn't count that much for the test, just I think like 4 out of 100 or something, 4 points out of 100. But nonetheless, this is something you're expected to be able to do. Okay, so let's do it. Okay, let's get this out of the way. All right, so how do we solve something like this? So you have to know what's the impedance means. Impedance is a kind of concept related to resistance. Let me close this door in the back. So impedance is related to related to resistance. So so in a circuit, in a circuit over here, the way we know the impedance, let's just say current in this, of course, going to go back and forth. Sometimes the current will be this direction, sometimes the current will be that direction. So at some time it's going to be current like this. And impedance, the current will be also sinusoidal with this sign. This one is a, let's call this, this quantity is sometimes called omega. So this Vt is given to be 300 sine omega t. Let's call this quantity V0. So V0 is given to be 300 volt and omega is 400 per second. Okay, so we think of this way. Then what IT will be, I can write in sine. What IT will be a combination of sine will be something like some A sine omega t plus B cosine omega t. That's all you see, no matter what the impedance is. And Z will go into finding what A and B are. If you have a combination of these two, you can also, so if I can write I, let's write over here, I of t will be A sine omega t plus B cosine omega t. And you can combine them by just write as a sine using some formula. So you can write down I0, a constant, sine omega t plus some phase, I'm going to call phase of current. And similarly, you could have written this guy as V0 sine omega t plus phase of the voltage, this property V of this. If you write like that, then what we have, we could say the phase of the voltage given to be 0. So we have two sinusoidal varying things. The only thing matters is what the difference of phase is. So one of them can always pick 0. Then you can't pick everything else is 0. Everything else will be something else. So that's how it turns out. And you will find that impedance is kind of related to relates I0 to V0 and also relates phi I. Okay, so phi I depends on impedance, I0 depends on impedance. So the way I like to think about that is impedance as a complex quantity in general. Whenever dealing with sines, cosines, it helps to think of that as complex quantity. So this is a little bit advanced, and then we are going to have to learn a little bit. So when you have something complex quantity, you introduce I is square root of -1, and so you can write Z as Z real plus Z imaginary, not current, but as Z imaginary. So this is the imaginary part and this is the real part. You can also write complex number is some amplitude of z, e to the power I, like phi, phase of z. So you see the you can phase taking care of the phase things becomes much easier if you do it this way. Okay. Okay, so this is so the way how you get the, if I give you a complex quantity and I want to get just this, I want to get the phase, you can write like that, you can get the phase. All right. And you can also write e to the there's another really incredible formula in complex quantities. If you think in terms of complex quantity, another incredible formula is e to the power I of a complex I of, say, theta. So this is real, and this is I squared. If this thing is actually cosine theta plus I sine theta. So if I were interested in just picking up the sine part after I do all the calculation, I can say, hey, give me the imaginary part of e to the power I theta. Then that just becomes sine theta. I just want it to as cosine part, then I would say, oh, give me the real part or e to the power I theta. Then this will be cosine theta. One more thing I would say is e to the power minus I theta just becomes cosine theta minus I sine theta, which you can just get from here. This is called Euler relation, and this really helps a lot of calculation. So why do I say this? I would say so any sine or cosine can be written as a complex, and then you can do all the calculations complex and come back to a real way. Okay. So I would do it over here. So I have a v of t is v0 sine omega t as our voltage. Then I can write v complex of t is v0 e to the I omega t. So I just complex this process, just writing things this way is like, okay, I'm gonna complexify it. So like a complexified. And if somebody gave me this thing, I can get my original one. So v of t is just, I'm gonna take a imaginary part of v tilde of t. Okay, so I can get back my original one from here back to original one just by capturing its imaginary part, just like over here. All right, this is well and good. So what do we have to do with my problem of circuit? In the circuit, when you complexify it, you get current by simply Ohm's law in the complex world. So you can use Ohm's law. Good, right? Very cool. Ohm's law in the complex world. And then you can get the real part always. So I just pick a tilde so that you don't get confused with you're in the complex world or you're in the real world. So if you have a complex world, you just get like this. 1 over z tilde is called actually admittance. The z tilde is called is still called impedance, and sometimes called complex impedance. So 1 over Z tilde is called admittance, complex. I don't have a whole bunch of time to tell you how the impedance of different elements will come, but I'm going to write them as if I know the answer. This is actually just if you have just a resistor, then complexity is just a real number. So if you look at it, it's just a real number. If this is real, if this thing is real, this is 0. In the phase part, this phase has to be 0. Just this is real. Okay, so Z tilde is like this, and Z tilde of just this, and if source is omega t, so if current just has a IT which has a goes as sine or cosine omega t, or cosine omega t plus some other phi s, phi c, okay? If the time part dependent is omega t in real way, okay, then this is going to be just I omega L. So this is this is pure imaginary. If I am capacitance and the current through that is this kind of behavior, okay, then is impedance will be minus I over omega c. So you write all of them, and so if you have 2 of these, 3 of these, like if you have like so this will be like a Z tilde R and Z tilde L, but they all like act like resistance. So this whole thing will look like R plus I omega L. This will just look like this. So it's actually a complex number here. So the Z is together is like that. So Z together is R plus I omega L, and we need to convert this into a phase information and amplitude information. So the relation between these guys, what will be the relation between these guys? Well, let me write that down also. This part you can study more in some other books, okay, but I'm just going to write down here, I'm going to use it, Z I squared. So imaginary part plus real part, square plus square. The way you can see this is you can actually draw a picture. So this is ZR, ZI. So draw X and Y diagram. And this is like a polar representation. And this is the phi Z. And that's where the Z complex is. So I should have actually called this Z complex here, just to be consistent with the notation. So over here, Z tilde will simply be square root of R square plus omega square L square, and phi Z will simply be arctan inverse omega L over R. Okay, let's work out this using this. I'm gonna work this out here. I think we have enough introduction to this. Where can you find this? Actually, this website. If you go to the AC current section in this website, you will find more detailed and many more examples worked out, as well as for you to work out. All right, so let me work this one out. So this is simply, so if I look at I here, I tilde will simply be V0 over Z tilde, which is just R, e to the power I phi V for that. So the magnitude will be this divided by that, and the phase will not remain changed. So I'm looking for the imaginary part. If I'm if I'm looking for, oh, I didn't do this here, but here completed. So if this was like it's the imaginary part that takes me from V tilde to V, it's the imaginary part that takes me to the real part, real way, imaginary part of I tilde. So I do the same thing as I do over there. This will, if this was cosine, then I had to take a real part, and then I have to take a real part here. If this is sine, then I have to take imaginary part to get my real values, actual values that's in my apparatus or my instrument. And so this is you have to do imaginary. So over here I have to take imaginary parts. So V0, let's look at the values. Let me get a green pen. So green. Okay, so this is oh yeah. Okay, so this is 300, and this is 30, and this phase is simply omega t. There's nothing else there. So if I take imaginary part of this, then the current, which I should be able to plot, will be 10 sine 400t. 400t is, this whole thing will go from 0 to 2 pi, 0 to 2 pi for one cycle. So that's what this is, 0 to 2 pi. So let's look at, we're plotting this. This is the I of t. Plotting this, so it's going to go from plus 10, so minus 10 to plus 10. And at t equal to 0, it will be 0. T equal to 0 is 0. Okay, so, and it's going to be same, just a regular sign. So it could be this guy, regular sign from 0 to 2 pi, but the magnitudes are not correct. It's going to plus 5 and minus 5. This plus 5 is still not correct. This could be correct, and this is going from 0 back to 0 over one period. It starts at 0. So this is, so the P is this guy. P is this guy. Okay. P goes to 3. So it could be, right away we ruled out these guys. So my study is to just then look at what will distinguish between these two guys. R can't distinguish, S can't. So I have to do Q, right? The Q will distinguish between A and C. All right, so let's do just the Q. I'm just doing Q will be enough. So to do Q, I will do other ones, but maybe the other ones leave it as an exercise for you. And then the bottom, I'll give you some time to do, and then at the bottom you can see my answers. Okay. So Q, just to distinguish, so this is the L, and this will be if I go for so over here it says going to be I omega L. So this will be Z tilde R equals to 30, and Z tilde L will be I omega L. Okay. So I omega L, so I'll get Z tilde will be I omega L is I times 400 times 100 milli, so 0.1, so I 40, so Z tilde 1 is 50, right? Square root of 30 square plus 40 square is 50, and phi Z is going to be I arctic 40 over 30, which is 4/3 is about like a 53 degrees or something like that. So all right, so which will be a little bit less than little more than a quarter cycle, right? 1/8 of a cycle. So it's like a so like I 206 of I mean 180 will be like half the cycle, 90 will be a quarter cycle, so 40 degrees will be 1/8 of a cycle. Okay, so over here when you have that situation, when you got I tilde equal to V0 e to the phi V, and you have a Z magnitude e to the I phi I. For this guy, this by dividing, you can see that V0 over Z magnitude e to I phi V minus phi I. And that will tell you that if I take an imaginary part of this I tilde to get I of t, then I'll just say V0 over magnitude. So this is the magnitude part, and then it will be sine phi V minus phi Z. So what we expect here for the current for the Q to be 400 divided by 50. I mean, I'm sorry, 300 volt divided by 50 sine 400t minus 53 degrees. So like a 53 degrees over 180 pi. That's what. So this degree is degree. So you can just say 50, whatever helps you. Even if to look at this, you can, for the rather than doing calculation, you can just say, oh, let's see 60 degrees. Then let's see 1/3. So this is like a pi/3 approximately. But still, what matters is this negative sign. Okay. Now, this telling me is going to go between, so this is 6. So this is telling me it's going to go, this thing is going to go, I of t is going to go between -6 and +6. So it could be possibility. So this is going from -6 to +6. And let's see if anything else is going to minus, this is going through -6 to +6. Okay, so this one, uh, if I just plot the voltage here, voltage will go, let me just, for the reference sake, because this part without this is the voltage. So if you plot the voltage part, um, oh, voltage will, of course, a different scale, but let's, and if I plot the voltage, we got to distinguish between these two guys, right? So plot the voltage part here. Oh, so if you look at the same points here to same points like this, the peak of this, um, just t equal to 0. Let's put a t equal to 0 just to compare. T equal to 0, voltage is 0, but t equal to 0, I 0 is going to be less than 0 because this negative sign, because this will go away for t equal to 0, so sign of negative will be negative value, like say pi over sine 30 degrees, and this sine 60 degrees is called 3 over 2, so it's going to be some negative value, a little bit less than 6. So and with the negative it's going to be somewhere, so it's going to be this is a t equal to 0 for the current matches with what I get, but this at t equal to 0 is giving positive value. This must be wrong. So q has to be 5. Q has matches with that, and actually that's enough to say that p is 3, q is 5. So this is the answer. So the A would be the answer and C would not be the answer. And then other one is R2, S1. You can actually work it out. Okay, so see, already you know the answer, but okay, I'm going to skip over this. Okay, so because I already solved, so A is my answer. In test situation, you don't want to just waste time on things that not gonna make a difference, right? This is not gonna make a difference. But you say maybe I'm wrong about some of these, so maybe I should actually maybe if you're not sure about Q, maybe you're sure about P but not sure about Q. So if you say you're sure about, then you'll be over here. Then you have to check one of the other guys. So let's see if we can check another one. Let's check R. R is going to be like that. Okay, so check R. Like I already know the answer, but check R. So R is going to be, now it's going to be really a little bit complicated, right? And so you might say, oh, I have to check R or S, but you know, between, if P you're sure of, then P3 and P3, you have to check just Q. But suppose you're not sure of P, but you're sure of Q, so Q5, so you have to check this guy. Checking R, is that a good strategy between this and this? Because say you're sure of Q, but you're not sure of P for some reason, then you have to check S, right? So that's the strategy for taking tests, that you should check S. But anyway, let's check if R is 2 or not. So but R is more complicated. And let's look at what the Z tilde will be for this part R. And that's going to be, let's write down over here. Z tilde will be, now I've got this guy, which is going to be 30, but this guy is going to be minus I. So let's write over here, minus I. Omega is 400, and you have 50 microfarads. 50 times 10 to the power minus 6 plus 30 plus I 400 times 0.025. And without having a good strategy of doing this, you're going to waste a lot of time. So this becomes minus 3, and so you make 1,000, and 20 divide 1,000. So 5 divided 1,000 is 200, and 4 divided 200 is 50, and this one is going to be so 1 and 2 pushes 1 and 2, so it's going to be 10. So we have minus I50 plus 30 plus I10 is now 30 minus I40. Over there, we had this guy was Z tilde was 30 plus I40. Over here, we have a minus I40. We don't have to really do a whole bunch of work now. So it's the same thing. Once you work this out, it's going to be 50, and face of the Z will be minus arctangent 4/3. That just will mean I tilde will look like V0 over Z e to the power I 400t, and this is going to minus becomes plus 4/3. So we get a real IT. This time we're looking for imaginary part of I tilde. This guy is, let's calculate over here so that we know 300 for V0, 50. So this is just 6 sine 400t plus, this is like 50 roughly. We talked about 53 degrees, around 53 degrees. Okay, so we can either go up or go down, can 45 degrees, or you want to go, let's keep doing, let's call it 60 degrees, okay, for easy calculation. So again, if you look at a t equal to 0, this is going to be 6 times plus square root 3 over 2. And it's going to go between plus and minus 6. And a t equal to 0 is going to look like this. So this is going to be plus, and looking at that, of course, this can't be case because it has to be in this part, the value of t equal to 0, but it's to be plus and minus 5, so the range is not correct, but this is not correct for this one. Yeah, this one is looks like could be correct, because start from here, go down like this, and at I0, and let's see, this is going from plus minus 6 to plus 6, so this is correct. So this would be 2. And you can go rule other guys out, but you can say R turns out to be not that one. R turns out to be 2. Let's say R is 2. Turns out R is 2 for this one, also wrong one. But similarly, I can check S. Let's check S out over here. So S has also 3 elements. So I got minus I omega C plus just R plus I omega L. Okay, so minus I 1 over omega is 400, and this is 50 microfarad, which is 10 to the power minus 6. This time is 60, not 30. So each one of them has different numbers, so we've got to be careful. I just almost made a blunder here. 400 times millihenry 0.125. Okay, so we do more or less same thing we did earlier. So this 0, this 0, this 0 makes it 10 to the minus 3, and bring it over there, make it 1000, and 5 kills makes it 200. 4 kills is the same number. Yeah, it is the same number. So this is I50. Now this guy is going to be 0, makes 1 go over here. You can see 1 0 makes this guy over here. So 12.5 times 4. You can see this is going to be actually equal to 50. So I get minus I50 plus 60 plus I50. Oh, this guy cancels out. So there's no phase difference. So this is just like as if these guys are not even there as far as the phase is concerned. But they're there because this is so this I can just the resistance as with this resistor circuit. So I can just write down I of t is just going to be 300 over 60 sine 400 t. So t equal to 0 is 0, and this is, so it's going between plus and minus 5. It's going between plus and minus 5. So we're going to look at what's going between plus and minus 5 and looks exactly like sine. So this goes between plus and minus 5 and exactly looks like sine. So this is the answer for S. So S will be that possibility. So let's make sure, yeah. So A was correct. So S is correct. Okay. Now I've shown you in a like complex notation form, but you could solve this problem using just a thing called a rule. Let's look at an alternative. So you say Eli, the ice. So you look at this mnemonic, which is EMF in an inductive circuit, EMF in an inductive circuit leads current. E L I. So this is for E, this is for L, and this is for I. And the Iceman means ice means current in a capacitive circuit leads EMF. So I C E. So you can use this. So you look at so in a circuit you look at X. No, don't look at Z, but you look at XL, which will be like omega L, and XC 1 over omega C. Okay, and compare which gonna dominate. All right, and so you say current will be I0 sine omega t plus, I won't have to just look at, okay, I will not calculate this, okay, like the way I did over there, which is a lead or lag, okay. So if I am in this circuit, this all L and R, so this will be inductive circuit. So if I think of current will lead, so we represent them as vector as a arrows. So this angle will be represented as arrows. This will be like a at angle phi. Of course, they will have different size arrows because it's different units. If this is voltage and the current, and they all rotate in a counterclockwise here. So this phase is always bigger than that. This will not be the case. This will be actually wrong because you want this to lead. So this is Eli case. So in Eli case, it will be just the opposite. So if the voltage was this way, you want current to be like that way. Okay, current be lagging behind. So in a plot, if the voltage, if this was the voltage plot, then if this is the voltage plot, so if you kind of continue this backward, so the peak of the current will be you can see it's going to have to at t equal to 0 is kind of it's kind of like a little bit like this. So it's going to be a little bit. So if I see LR circuit, this was the LR circuit over here, and that was I was current like this. So you can just from Eli the Iceman, this will if this is zero, this guy's zero comes after the zero of the voltage. This the voltage zero comes at some t equal to 0, but this guy is t plus at the current 0 comes a little bit later. So this is the inductive circuit, and we look at it, we'll say, how about this guy? Well, this guy, the difference is the voltage is this also inductive, but a current is varying between 20 minus and this is plus 5 and minus 5. So that's why this guy can't be the case. Now, this guy with no phase difference with voltage, so is purely resistive. And if you work out the same way, Eli the Iceman, so this is like ice thing. So this is will be conductive. Capacitive, and this will be just resistive. So if you we saw that this guy was for R, right? So if you look at R, 50 microfarad and 25 millihenry. So if you look at 50 microfarad and 25 millihenry, and you say, what is my XC versus XL? So this will be 1/400 times 50 times 10 to the minus 6. And this whole thing was, I think it's like 50 ohm, and XL will be 400 0.25 025, and so this guy become quarter of 40 is 10 ohm. So clearly XC is bigger than XL. That makes it capacitive circuit. So here, what are we going to get? If we have, this is the voltage. So this is Eli, the Iceman. So this is Iceman, capacity ice. So current will lead EMF. So current 0 will be before this guy is 0. So current 0 will be over here, and it will be sine. So current 0 will be here. So it's going to be like that. So this is t equal to 0. This part is not given to us. So this is where I'm going to see the current function, and this is the voltage function, and this is there's only one of those plots like that. So you can actually just don't have to do complex analysis to get the answer. You can just do Eli the Iceman, and that should be okay. But you have to know how to read the Eli the Iceman properly, okay? Using so Eli when XL is greater than XC, and ice is when XC is greater than XL. Of course, this does not give you actual phase. give you phase value. It just tells you which is ahead, which is behind, but it doesn't tell you how much ahead, how much behind. For that, you have to do, a full vector calculation, or you have to do complex work. There's an alternative to that, but that would take me too far off, and so I'm going to stop here. It's already, we talked a couple of different ways thinking about it. Hopefully you can have more practice doing similar problems. Let me stop. I'll see you in another video. Bye.